So now we'll look at 2.4, and 2.4 is a really, really quick section. And this should be a review for most of you. 2.4 is all about slope. And when we talk about slope, well, slope is defined as rise over run. And the rise is the up and down component, so that's your y. The run is the x value, and that's your left and right. Now, when we talk about slope and graphs, there are 4 different outcomes from the slope. So we're going to look at 4 lines here, and we're going to talk about what the slope of these 4 lines are. The first one is going down from left to right. And if it's going down from left to right, then that means my slope is negative. It's just like looking at a graph of a stock. If the line's going down, it's decreasing, and it has a negative slope. If it's going up from left to right, like this one here, then that means my slope is positive. And the last 2 are your vertical and your horizontal lines. If we have a horizontal line like that, then my slope is 0. And if we have a vertical line, then my slope is undefined. So this is what we've got. So if it goes down from left to right, it's a negative slope. If it goes up from left to right, it's a positive slope. If it stays constant in a horizontal line, it's 0. And if it's a vertical line, then my slope is undefined. And the easiest way to remember the 0 and the undefined part is think of a roller coaster. So if we're on a roller coaster and we've done the ride and we're going back to the station, there's a flat part here, and that can be done. That's a slope of 0. So as the roller coaster comes back to the station, so that everyone can get off, that has a slope of 0. We can do that. If you rode a roller coaster before, they always have some type of slant to them. You can never do just a straight down drop. So that's undefined, and that's not possible. Because a roller coaster can't do that. It can go down, it always has a little bit of a slope to it. So you can't have something that just drops straight down, because that wouldn't work with the cars. So that's the way I remember the vertical and the horizontal lines. I think of the 0 as the roller coaster coming back to the station, and then a vertical drop off, a straight vertical drop down. We can't do that on a roller coaster, so that's why it's undefined. We can graph a line a couple of different ways. We can graph a line with 2 points. We can plot the points, and we can connect them together. We can graph a line when I give you a point and a slope. And we can also graph a line from an equation. So let's go ahead and graph this line when you're given a point and a slope. So let's go ahead and try to graph this line, and this is a very, very easy section to work through. So let's graph this line, and let's say you're given a slope of minus 2/3, and you've got that point to start with of 5, 3. So we want to graph this line, and we're given a point and a slope. So how do we graph a line when we're given a point and a slope? Well, very, very simply, we start by plotting our point. So we find our initial point, which is 5, 3. Students sometimes get this confused. X is the first component, Y is the second. So 5, 3 would be over 5 units, and then up 3 units. Make sure you don't get the X and the Y mixed up. So there's 5, 3. Now, what kind of slope am I given here? Well, you're given a negative 2/3. So that tells me my line is going to be going down from left to right. And how do we determine the next point? Well, we start right here at our 5, 3, and we have to go down 2 units, because this is your Y part, this is your X. So we're going to go down 2 units, and then we're going to go over 1, 2, 3 units. So down 2, over 3. And make our dot. And that is what we need to get our line. We've got our 2 points now. We can connect them together. So all you do is simply plot your point and then move with your slope. So we started at 5, 3. Our slope was a minus 2/3. So what did we do? We went down 2 units, and then we went to the right 3 units. So plot your point, and then go up or down, and then over. We'll do one more of these, and then we'll look at either a vertical or a horizontal one. So let's do one more. We plot our point and use our slope. So same directions. We're going to graph this line. And you're given a slope of 5/4, and you're given the point 4, 2. We want to graph this line. So we find our point 4, 2. Remember, this is your X, this is your Y. So 4, 2 would be over 4 units. Over 4 and then up 2. There's our starting point, which is at 4, 2. So plot our point first. Now, once we have the point, what do? We move from that point the number of units that are in our slope. So in this case, our slope is 5/4. So we're going, and it's positive, so that means we're going to go up 5 and over 4 units. So from our point at 4, 2, we're going to have to go up 5, 3, 4, 5. So we'll go up 5 units, and then we'll go over 4 units. So up 5 and over about 4 units. We make our second dot, and then we can connect them together. So you plot your point, and then move according to your slope. What about an undefined slope? Well, an undefined slope, what is that? An undefined slope, remember, is a vertical line. So let's try to graph one of these. So we're going to try and graph the line. And let's say you're given a slope that is undefined. And we've got the point 2, -3. So we know that an undefined slope, what is that? Well, an undefined slope, that's going to be a vertical line. So that's going to be a vertical line here. And where do we start at? We start at our point, which is 2, 3. Or sorry, 2, -3 here. So that's over 2 units and down 3. And we've got our point. Our slope is undefined, so that simply means that it's just a vertical line, just like that. So that has a undefined slope, so it's a vertical line. So we can graph a line with either 2 points, which we did in 2, 1, or we can graph a line from a point and a slope. We can also graph a line from a function. And so now we'll go ahead and graph this one. We'll do a couple of these as well. And we're going to graph f of x equals 2x minus 1. So we want to graph this function. And this f of x, remember, is the same as y. So that's the same as y equals 2x minus 1. So that y and the f of x can be used interchangeably. And once it's been solved for y, then we know the number in front of the x is the slope. And that -1, well, that is your y-intercept, which is 0, -1. So once that has been solved for y, we find our slope and we find our y-intercept, and that's our starting point. Well, we're also going to get the domain and the range. So we'll start with our y-intercept, which is at 0, -1. So that's right here. So just like we did a moment ago, we plot our point first. And then what's our slope? Well, our slope is 2, so I'm going to write that as 2 over 1. So that means we're going to go up 2 units and over 1 unit. So we're going to start here at that 0, -1. We're going to go up 2 units, and then we'll go over 1 unit. Make our new dot and connect it together. And we also need to find our domain and range. And we covered this last time in 2.3. The domain is the x values. The range is the y values. So let's look at our graph here. Okay, with this x, the values first. We'll do the domain first. So look at what happens to our picture here. Now the arrows mean it goes on forever. So this is going to go up and continue on to the right and down and continue down to the left. So it goes to the left and it goes to the right. So my domain would be negative to positive infinity. What about the range? Well, this can go up through the ceiling and down through the floor. So my range would also be negative to positive infinity. Okay. Let's try another one. Let's try to graph y equals minus 3x. So we want to try and graph y equals minus 3x. Well, what's different about this one? There's no number on the end. So if there's no number on the end, that's like having a plus 0. And so that means our y-intercept, our starting point, is 0, 0. And that negative 3, well, that's going to be my slope. Is the number in front of the x. Once it has been solved for y, is your slope. So we plot our point 0, 0 right here. Our slope is a negative 3 over 1. So we're going to go down 3 and over 1 unit. So from our starting point at 0, 0, we go down 3. And then we go over 1. Make our new dot. There is our graph. And we need to find the domain and the range again. And the domain and the range, just like the last one, is negative to positive infinity for both. And all these lines, as long as it's a diagonal line, is going to have a negative to positive infinity for the domain and the range. So all these diagonal lines have the same domain and range, which is all real numbers. I want to look at one more. And this one is a constant function. So how about we graph f of x equals 4? And this is called a constant function. And it's a constant function because it doesn't ever go up or down. So it's a constant value. And f of x, remember, is the same thing as y. So this is the same as having y equals 4. Now, if we tried to graph y equals 4, well, where do we start at? Our y value is going to be at 4. So we're going to start up 4 units. It's a constant function. So that means we have a horizontal line just like that, because constant functions have no x value. So f of x equals 4 would just be a horizontal line at 4. And we know the slope of this would be 0, because horizontal lines have a slope of 0. It does have a little bit different domain and range. Now the domain is the x values. So as you can see, this graph can go to the left and it can go to the right. So my domain is the same, and that's still negative to positive infinity. The range is the up and down part. So this graph can't go up or down any. So this graph is stuck at the number 4. So your range would simply be the number 4 then. If it has not been solved for y, to graph it, you're going to have to solve it for y. So let's try one where it's not been solved for y. So let's try to graph 4x minus 8y equals, let's say, 16. So I want you to try to graph this equation. Now this again is going to be a line. Okay, so we're going to graph this as a line here. We need to first solve this for y. So it has to be slope-intercept point. So we need to take our equation and we need to first solve this for y. That way we can get our slope and we can get our y-intercept. So we'll move that 4x over. And now we've got a minus 8y equals a minus 4x plus 16. We'll divide by our negative 8. And that reduces down to be y equals negative and negative makes it positive 1/2 x. And 16 divided by 8 is a negative 2. So there's my slope, which again is a half. And that negative 2 is your y-intercept. As an ordered pair, that would be 0, negative 2. How do we graph it? Well, we find our point, which is 0, negative 2. Our slope is 1/2. So what does that tell us then? We've got to go up 1 unit and over 2 units. So from our y-intercept at 0, negative 2, we're going to go up 1 and over 2. Make our dot, connect them together. On these, you also need to find your domain and your range. And that's the easy part, because all diagonal lines have the same domain and range. A lot of times, instead of writing out domain and range, I'll use a D and an R. And my domain and range are both negative to positive infinity. So we get it in slope-intercept form. And we find our slope. We get our y-intercept, and we plot our point, our y-intercept, and use the slope. One last part of this section is working with ordered pairs. So how do we find the slope when you're given two ordered pairs? Well, we have a formula that we can use. So this is going to be for ordered pairs. So for ordered pairs, we use the formula m equals y1 minus y2 over x1 minus x2. So that's going to be our formula for finding the slope. And this finds the slope. So we'll do one of these and then we'll look at a couple of applications. So let's go ahead and find the slope here. And you're going to be given two ordered pairs. So let's say you're given 3, 5 and 8, 1. And I want you to find that slope. And I'm sure you've done this in previous courses before. It's actually a little bit easier than the distance formula. You just label x1, y1, x2, y2. So we label our ordered pairs. I always like to write our formula down, which is y1 minus y2 divided by x1 minus x2. Plug in our values, which is 5 minus 1 over 3 minus 8. Remember, your y is going in the numerator, x is going in the denominator. 5 minus 1, that's a 4. 3 minus 8, that's a minus 5. Bring that negative up to the top. So my slope would be a minus 4/5. And that's all you need to do there. So use your slope formula with the provided ordered pairs now to calculate that slope. And let's look at a couple of quick applications from our textbook. These are not going to be difficult. All we need to do is determine our ordered pairs, which one's the x, which one's the y value, and find the slope. So we'll pick out a couple of these from our textbook here. Let me find a couple of them. Okay, let's look at question 69. And if you don't have your textbook with you, that's fine. We'll put it up on the screen here. We're going to look at question 69, and then we'll do 70 as well. And what we're doing is we're looking at the dropout rate of high school students. So in 1980, the number of high school students that dropped out in the United States was 85,000. By 2016, this number had decreased to 2,334,000. Find and interpret the average rate of change and the number of high school dropouts. And they want you to round your answer to the nearest tenth. So what are we going to look at here? Well, average rate of change, what that is that's a fancy word for your slope. So average rate of change means the slope. And let's come up with our ordered pairs. We're going to label our ordered pairs as x and y. Okay, and x is going to be the years. Y is the dropouts. Normally, time is on the x-axis, so time is always going to go first. And unless it specifically tells you a different way, anytime we work with time, time is an x value. So let's come up with our ordered pairs. So when we first read this problem, we're looking at the year 1980, and we had 5,000, 85,000 dropouts. So that's your first ordered pair. So time always goes first. So in this case, we're looking at the time and the number of dropouts. So dropouts is going to be the y. Time in this case is in years. That's your x value. What about in 2016? Well, in 2016, the dropout rate had fell to 2,334,000. Now we've got everything that we need to find our slope. Okay, and let's see, just before we even work it out, do you think this slope is going to be positive or negative? Just by reading the question. Okay, what's happened to the number of dropouts? It's decreasing, right? Because we've done all these different programs to keep students in school. So when we look at our slope should be a negative value because fewer students are dropping out. Okay, so our slope should be negative. So let's go ahead now and find our slope, which is y1 minus y2 over x1 minus x2. And label our ordered pairs, x1, y1, x2, y2. Okay, so fill in the blanks here. So we've got 585,000 minus 2,334,000. And we're going to divide that by 1980 minus 2016. And they want us to round now to the nearest, nearest tenth of 1,000, okay? So we're going to go ahead and find that value, and then we're going to talk about what that value means. So let's work it out and see what we get. So we have 5,085 minus 2,334, and that gives you a difference of 2751. Down below, we've got 1980 minus 2016. That's a difference of a minus 36. And then we divide those out. And that makes it a minus 76.4. And that's going to be 1,000 per year. So what is that telling you? Well, that's telling you that every year we have managed to decrease the number of dropouts by about 76,000. So about 76,000 fewer students are dropping out of high school every year from that time range of 1980 to 2016. So that's what that's meaning. And it's negative because the number of dropouts is decreasing. We've came up with all kinds of federal programs and state programs to help with that. So obviously you can see that there are fewer people dropping out because of a lot of those programs. Question 70. Sorry about that. That's page 248. These are both on page 248. You're welcome. Question 70 is similar again. And we're looking at the number of people that watch the Academy Awards. So the percent of all TV households in the U.S. that tuned in during a live broadcast of the Academy Awards changed from 27.9% in 2014 to 18.9% in 2018. Find and interpret the average rate of change in the Academy Awards viewership in percent per year. So what's happening to that? Well, not as many people are watching the Academy Awards anymore, right? It's just not as popular as what it used to be. So every year it's decreased a little bit. Darken that up a bit here so it's easier to see. So every year it's went down a bit, and we want to see what percentage is going down every year. So let's come up with our ordered pairs. Now, always remember, X is time. So in most cases, it might be different in some particular instances, but if it is, they'll tell you. Okay, but generally speaking, time is the x-axis. If you think about graph of a stock, okay, the years are down at the bottom. The value of the stock is the up and down part. So time is always going to be the x. Doesn't matter whether you're looking at number of bacteria in a petri dish. If you go to graph that, what's along the bottom, along that x-axis, that's your time. Along the y-axis, the up and down part, that's the bacteria. So if you're looking at something from microbiology, x again is the time, y is, in this case, the percentage, or time or year, and x is going to be the percent. So let's find our two ordered pairs. And we've already talked about how the viewership is decreasing, so it should be negative. and we looked at 2014, and that was at 27.9%, and we don't need the percents there. We'll put those on at the end. And then we looked at it again in 2018. And 2018, that was 18.9%. So let's find our slope. Remember, that's y1 minus y2 over x1 minus x2. Plug in our values, and sometimes it helps to label them. x1, y1, x2, y2. So plugging in our values, that would be 27.9 minus 18.9 over 2014 minus 2018. So let's quickly work this out. And there are several applications in your homework. That's why I wanted to go over a couple of these. They're not difficult. It's just a matter of setting up those ordered pairs. So we've got 27.9 minus 18.9. That's a difference of 9. And then we've got 2014 minus 2018. That's a minus 4. And when we divide them out, we get a minus 2.25, and that's going to be percent per year. And what again is that telling you? Well, that's telling you that every year we lose about 2.25% of the number of people that watch that Academy Award. So every year it's decreasing. People just don't watch it like they used to. That should now finish up 2.4. We're going to start 2.5, and we should be able to finish up 2.5 today. So we're going to go ahead and start 2.5 right now. And 2.5, we're going to be creating the line equations. So instead of using the line equations to graph things, what we're going to be doing now is we're going to be coming up with our equations for these lines. And there are two ways to write your lines. You can either write your answer, your line equations, in what's called slope-intercept form, which is y equals mx plus b, or you can write it in standard form, which is ax plus by equals c. For standard form, they all have to be integers. So no fractions or decimals. So when we talk about standard form, all of them are integers, no fractions or decimals, and a must be positive. So a's got to be a positive value, so it has to start off positive, no fractions or decimals. And if we've got fractions, we just clear them out. So these are the two ways that you can write your answer. You can either write your answer in slope-intercept form, or you can write your answer in standard form. And the question will tell you specifically which way to write your answer. We're going to start off with the first case, and there are 3 cases. So we're going to start off with the first case, which is how to find the equation of a line when you're given a point and a slope. And I use a flow chart for these because I think that this is the absolute easiest way to work them out. So we want to find the equation of a line given a point and a slope. So we want to find the equation of a line when you're given now a point and a slope. And there's going to be three different flow charts. We'll look at the two others after our break. But we're going to start off with this one. So we want to find the equation of a line when you're given a point and a slope. And this is the easiest one. All we have to do is use point slope. And point slope is y minus y1 equals m times x minus x1. And then once we've used that point slope formula, then we can either write our answer in standard form or in slope-intercept form. And slope-intercept form looks like this again. Which is y equals mx plus b. And standard form is going to be over here, which is ax plus by equals c. So we've got the slope-intercept form, and we've got the standard form. This is the flow chart that we're going to be using when we want to find the equation of a line, and we're given a point and a slope. So we apply our point slope formula, and then we find our answer in either slope-intercept or we find it in standard form. So let's work out two of these, and let's find the equation in slope-intercept form. So we're going to try to find our equation in slope-intercept form. And let's say we're given a slope of -5, and we're given a point that is 2, -4. So I'll give you a minute to get everything written down here. If you need to, move this up so you can see the rest of this flow chart. Okay, so there again are going to be three flow charts. This first one is we're going to find the equation of a line when you're given a point and a slope. So we've got a point and a slope. And this is the most basic one. So what do? We use point slope, okay? And then once we've got it in point slope, what do we do from there? Well, in this case, we want it in slope-intercept, so it needs to look like that. That's what our answer is going to look like, just like that. So let's go ahead now and work out this question. And we want our answer again in slope-intercept form. So we have a point and a slope, so we begin by using point slope. And this is y minus y1 equals m times x minus x1. And we label our ordered pair x1 and y1. Simply plug our values in. So that's y minus, and watch for double negatives, -4 equals -5 times x minus 2. So again, be very, very careful of those double negatives. We know this double negative here is going to make that a positive value. We're going to distribute that -5 through. So that leaves me with y plus 4 equals 5x. Negative and negative makes it a positive 2. Oh, sorry, positive 10. My mistake. So positive 10 there. Now, what do we want our answer to look like? Well, if we go back up and look, we want it to be slope-intercept. So it's got to look like that. And this one's very simple. Slope-intercept is solved for y. So what do? We move that 4 over. And that's it. So what's our final answer then going to become? Our final answer is then going to become y equals now minus 5x plus 6. So there's our final answer in slope-intercept form. So it's pretty easy. We'll do one more, and then we'll take a break. So one more of these. We're going to use the same process again. In this case, though, I'm going to have you write it in standard form. So we're going to find the equation. In standard form. You're going to be given a slope of 3/5, and you're going to be given the ordered pair -9 minus 3. And we want this one in standard form. Okay, so what do we do first? Well, what do we have? We have a point and we have a slope. So we apply our point-slope formula. And that is y minus y1 equals m times x minus x1. And this is x1 and y1 here. Plug our values in. Watch out for double negatives. So we have y minus a minus 3 equals 3/5 times x minus a minus 9. Those double negatives are going to make that positive here and over here as well. And we'll distribute that 3/5 through. So that's y plus 3 on the left. On the right, we've got 3/5 x. Now, that 9 is like a 9 over 1. So you can write that over 1 if you need to. 3 times 9 makes it 27. 5 times 1 makes it a 5. We want this now in standard form. And in standard form, we can't have any fractions. So we need to get rid of those fractions. So how do we do that? Well, it looks like our denominator is a 5, right? So we're going to multiply everything by a 5. So we'll do that. Distribute that through. And then clean it up from there. So distributing that 5 through, we get 5y plus 5 times 3 is 15. The 5's cancel, leaving you with the 3x. 5's cancel, that leaves you with the 27. We want this in standard form, so that means the x's and the y's are on the same side. So I'm going to move that 3x over, and I'm also going to move that 15 over. Now we've got a minus 3x plus 5y equals, we've got 27 minus 15, I believe that's a 13. Oops, sorry, 12, my mistake there. So 27 minus 15 is a 12. Sorry about that. This is not in standard form yet, though. Why not? Well, for it to be in standard form, it has to start off positive. This one starts off negative. So how do we fix that? Well, we just simply distribute a -3. And now we got our answer rewritten in standard form, which is 3x minus 5y equals a -12. And that is your answer in standard form. Okay. We'll go ahead and take a short break, and let's meet back here at 8:45. So let's try to meet back here at 8:45, and then we're going to finish up, hopefully today, most if not all of 2-5.